Good morning. If you did not finish the notes from yesterday, which most of us did not, go back to yesterday's video and go to the very end, and it should pick up any pieces that we missed. I think we only have one, maybe two little slides left. Feel free to rewatch the video if there was anything confusing. So today should be a little bit shorter of notes. So we are interpreting graphs of functions, different parts of a graph. So remember, we can make lines on coordinate planes, which we did yesterday, at least once. So we have these things called intercepts that I mentioned, right? We have a y-intercept, which crosses the y-axis, and that's when we have a 0 for x, and y has a number, a value. And then our x-intercept is when x is a value, and then y is 0. So when one of the numbers is zeros, we have an intercept. There's our y-intercept, there's our x-intercept. Those are helpful to understand. So how do we interpret things in math? Well, one, we can write the actual math with numbers. Two, add the labels. Labels will be very helpful today, not only reading them, but making sure you put your labels on your work. Add the x-axis label and the y-axis label, right? Work pretty good there. And writing a sentence. Notice it doesn't say you don't have to write a paragraph. We're not writing a 5-page paper. A sentence, okay? A sentence. So here, if we look at this graph of a real-world situation, so this would be the height of a golf ball. If we look at this, we know it's not linear. It's not a straight line. But that's okay. From yesterday, it does pass the function test, right? It passes the vertical line test, so it is a quadratic function. But our goal here is to find and interpret the intercepts. So what we're looking for is where it crosses the x and y axis. So the first one is our y-intercept. So I'm going to use a little highlighter tool. Feel free to highlight or color code or just use pencil. So our y-intercept crosses our y-axis. So we look for where the graph crosses our y-axis. Oh, look, there it is. And actually, what's interesting about this ordered pair is that it is 0, 0. Technically, that's the y-intercept and the x-intercept. This one, for quadratics, they always have two, not always. A lot of the times they have two intercepts because they'll cross the x-axis at 2 points because of that curve. So it crosses here and here, right? But we're going to focus on this one as our y-intercept at this point. What does it mean? Well, when we go for what it means, we're looking at the labels, right? Our x-axis labels and our y-axis labels. So 0 is our x. So if we look at this 0 distance from the t in yards. So it's our starting point, really, which is always usually the first 0 is where we begin. So the golf ball started on the ground. No, we don't want to put that. On the tee. That's where it started. Because distance from the tee, it's no distance away from the tee, so it's right there on the tee. Right where you start, at 0 yards away from the tee. You could write that, but that's kind of a weird thing to say. All right, the golf ball started on the tee. There's our 0 for our x-axis. It's implied. And you can make two different sentences. We'll make ours together. And then we got to get our other 0 here for our y-axis. Our y is feet. So 0 feet. Is it up in the air at all? No. It is on the ground. I mean, you could go for like that and don't put any numbers in there. You could put it's 0 feet off the ground if you wanted to. We have options there. But usually that starting point, there's those implied numbers there. Our x-intercept has a bit more numbers going on here. So let's look at our x-intercept. Is over here on our x-axis. Technically, this is also an x-intercept, but we already talked about it up here. I'm going to move to our second one. Ooh. So for this one, it's 119, 118. Let's go 119. I'm estimating. Okay, or guesstimating. 119 and our. So sorry. 119 is our x coordinate, and 0 is our y coordinate. So for this one, it means, well, notice one of those is still 0. So one of these parts of this sentence is still the same for this sentence. The ball is back on the ground. But notice it traveled, right? You hit it, boom, and then it falls back down and hits the ground. Now I know sometimes there's stuff after it, but hey, this seems like it was a hole in one. Just right in there. We'll go with that. That makes sense for the graph here. So our x-intercept is 119 is our x-coordinate. So the ball is 119 yards away from the tee and landed on the ground. Right? You can put that implied that, hey, we know it went up and then back down. It hit the ground at the end. Or you could even put it ended on the ground if you wanted to, because that's our end behavior there for our graph, is it ended right on the ground. All right, so that's kind of what we're doing here. We're making some sentences with our numbers and interpreting what it means in our real life situations. Baking cookies. That sounds delightful. Now this graph is a little strange and weird, and you can see it's linear. It's a line, also a function. Good job, good job. But it is a negative slope. I already left stuff on here from when I tried. Okay, so I'll just go for it here. So our y-intercept is way up here this time. So that would be 0, 20. Right, so it means, what does it mean? Well, if we look at our x-coordinate is 0, 0 batches of cookies are made. If 0 batches of cookies are made, we don't have any cookies. Not yet. Okay, so if we make 0 batches of cookies, and then we have our 20 for y, 20 is our flour, and C stands for cups. So that's how many cups of flour. Oh, so if we have 20 cups of flour. So if we make 0 batches of cookies, we will still have 20 cups of flour. Just sit right there, doing nothing. So that's our starting point. We started with no cookies and a bag of flour. 20 cups worth. So there's our y-intercept. And then our x-intercept, we look on our x-axis. Oh, right there. There we go. So our x-intercept is, I'd say that looks like 10. 0. So this time we have a number for our batches of cookies. We got 10 batches of cookies. Well, after making 10 batches of cookies, something's going to happen to that flour, right? We're using flour to make the cookies. And if we look, we have no more flour left. Some of you are already starting to imply, oh, that means there's 2 cups of flour per batch of cookies. And if you look, yes, you are using 2 cups for every one batch. 2 cups for every one batch. There's our slope, 2 cups for every one batch. But that's a little ahead of what we're doing. But hey, if you were wondering, that's where that 2 is. That some of you are thinking about. Now we're going to talk about end behavior. And this one I feel is really relevant to what we are working on right now, or not working through right now, is during a pandemic. This was a H1N1 was also a virus, not as, I guess, media filled as this one here that we are currently working with. But notice it has that same kind of curve. If you've looked at any of those graphs, it's growing exponentially. So it is a function. It's not linear, but it's a function. It's an exponential function. And if we look here, we're looking at the end behavior only. Let's go end behavior only. We could talk about where it started, 0 cases, and then it started to move up and up and up, right? We could talk about that. But if we are just looking at the end behavior, where is it ending? Well, we're just talking about the end behavior. That arrow is what we're looking at. So we kind of look at how we get to that arrow. How do we get to the end? Well, as we're moving more on our x values, right, we're gaining in our x values are increasing. They're getting bigger and bigger and bigger and bigger and bigger. So are our y values. So as x increases, y also increases. So as X increases, Y, and then it increases and appears, well, I'm spelling that wrong, to approach, oh no, I was wrong, so sorry. What number, not quite 12,000, maybe 11,000 cases, right? Reported cases, it's approaching there. So that's kind of what's happening in this graph. The end behavior of the graph indicates a maximum number of reported cases of 11,000. So then we talk about what that 11,000 represents in the situation, our reported cases. So yes, I did it in 2 sentences. That's all right. But we're looking at a relative maximum, the highest point on the graph, which is kind of up here, about 11,000. We could talk about the minimum amount, but that's 0 back by day 1, or 0. 0 was a good. So that's what we're looking for here for just the end behavior, how it ends. So let's look at our end behavior here. Oh, this is much more positive and happy. Oh, that happy point is for something later. So if we look at this here, David is saving for a car. And we can look at where it starts, right? Like that golf ball. Our y-intercept is here. David started with $1,400 in his bank account to save for this car. So that's where we started. And then notice it's consistently going up and up over the weeks. Oh, so if we're looking at how they interact, it's just like that. We don't approach anything. We just keep going, really. As the X values increase, Y values, right? As the weeks go by, he's saving more and more money. That's why it's a positive slope here. Everything is all increasing. The Y values increase. The X values increase, the Y values increase. And then you can put it to words, right? As weeks go by, David's savings gains money, grows, increases in value. I'm going to put increases. So now we're interpreting that 0.51800. Now notice we don't put the comma there. That way we don't get confused with this comma for the ordered pair. That's all. So we put 5 with its words. 5 is down here is an X value, so it's in our X axis as weeks. So after 5 weeks, David has saved, right? Because we kind of know where this is going here. 1,800 here. It's over here on savings. Has saved how much money? Well, we're labeling it with dollars. 18, and this would be a good spot for the comma. Oh my gosh. There we go. $118,000. $1,800 for a car. I don't know if it's a new car, used car, just a car. So we make sure to get those 2 numbers in our sentence and we put our labels on it. Pretty easy. So let's look at this one here, our end behavior. This one's also an exponential growth right here, but it kind of plateaus at this point. So if we are looking at the end behavior, we can go fancy schmancy. So this would be like an SBAC answer if we're going all the way from here and how it continues through the graph. So write small. You can summarize, I guess. But don't summarize too much. Make sure to get the meat. The average gasoline price is always positive. Notice it's still continuing towards that positive feel I'm pointing the wrong way for my video. That way, positive. So it's a positive graph. Our slope is positive, even though our slope is constantly changing. It increases for the first few years. Oh, I guess it does decrease a little bit. Oh yeah, you can see it. Decreases until about the 11th year. It increases. I mean, I would put forever, but we don't really need to put that. So our 11th year is good. Increases, right? So we talk about the whole movement of the graph. I lost my mouse. Where did it go? There it is. So we started out and went up a little, and then went down a little, and then went all the way up. So that's kind of a fancy schmancy SPEC answer. And then you could talk about the minimum and maximum. The minima are at 1 and about 11, because it dips at 1 and is low, and that 11 one is about the same as also low. So those are relative minimums. And if we get more curves, we're looking at all those bottom numbers. We don't really have a relative maximum. The average price appears to increase as time passes. So that's like that. As X increases, Y increases. And we're looking at the more general. We know it has a little dip here and it goes down a bit. But overall, looking at that kind of like best line of fit kind of idea. So now we're interpreting that 0.101 where the happy face is over 10 and up to 1. We just find what those numbers mean in context and put them in a sentence. So let's start with our 10 here. 10 is our X value. Oh, but 10 is not the years. So don't put after 10 years. You could put 10 years after 1987. You could also do the math there and put in 1997. You could put that too. It works. It's good. Either's fine, right? The price of, the average price. Don't just go for price. Look at that title. The average price of gasoline was about $1. Oh, don't just put $1. Look at that label again. $1 per gallon. Make sure you get all your units. So notice we used parts from our title. We used parts from our X coordinate, our X axis, and our Y axis. All right, we're moving, we're grooving. Here we go. Okay, our right whale population. Oh, this is a negative slope. So we're not going to just be increasing this time. Things are decreasing. Oh, those poor whales. Population. Oh. So if we're going again for another SPEC answer, shall we? Why not? The population is above 0 for the first 10 generations and then below 0. Talking about where that end behavior is happening. I mean, we're going down, and then notice that arrow says, technically, we're still continuing down lower. I don't know if that's actually possible in this whale population. There's more. A negative population is not reasonable. Makes sense, right? We can't have negative amounts of whales. And then you got to talk about that negative slope. The population is going down for the entire time. You could also put as X values are increasing, because we're still continuing through time, our Y values are decreasing. So the Y is going down. the x is consistently increasing because our x is usually time, and time just keeps ticking. There are no extrema. What that means, there's no minimum, there's no maximum. That's when we start to get those curves. Kind of draw curves there. But as the time increases, the population will continue to drop. Now, that's kind of repeating of this sentence. So I feel like you could use either that sentence there or the final sentence. I feel it's a little repetitive, but SPEC. Did I spell that right? Yes, I did. Apparently, it does not know the vocab word for this. It's not a very often used vocab word. Maybe that's why. Okay, so now we're going to interpret the point 6, 100. Oh man, I don't have my happy point on there. Okay, 4, 6, 100. There we go. Right there. What does that point represent? Well, we just use our labels. All right, so 6 is generations since 2007. So 6 generations past 2007. You can do some math too if you want. The right whale population was 100. You can make yours more grammatically beautiful. All right, so interpret the graph without scales. Notice we don't have any exact numbers, so we're just going to kind of talk words here for this one. So it's those same ideas as we're increasing and decreasing, but we need to interpret it in real life. So just kind of like with the whales, we talked about the whales, right? As the time increases, the population would continue to drop. So we're going to use the words increasing, decreasing. Those are good ones. And as we're moving through time, right? So as time is passing, we're answering questions, number of questions answered. Well, let's read. The graph below represents a student taking an exam. Oh, there we go. Now we have some real life context, right? You're taking a test. What happens? Well, if we look as the first few minutes happen, look, during that time, you're answering a few questions. So like after a minute goes by, you answered one question. Another minute, another question. Another minute, another question. Another minute, another question. And then what? Well, time is passing and no questions are being answered. Well, you might be staring off into space. You might be thinking. You might be working out the problem. You might take a break, go to the bathroom, get a drink, So there's this break point here where no more questions are being answered, but time is still ticking. And maybe that was like, took some work to solve, and then finally you answered it. Okay, continuing. Right? So we have to put words to this. Whew, sorry, my goodness. Whew. A student. So the student begins by answering questions as time goes by, then stops answering questions or takes a break or works out a problem, right? We could use any type of thing that makes sense there. I'm going to go for taking a break. How about that? Well, then stops answering questions. We'll go doesn't answer any questions. For a little bit and continues to answer some questions and stops answering questions and continues to answer questions. We could put consistently. I'm going to go as time goes on. Yeah, run-on sentences. Just make sure to put in some nice commas. Use your grammatical Englishy skills to make it fantastic. But basically, you're just explaining what happens. And you can kind of put in whatever you think would happen there. So this one here, the graph below represents the speed of a car as it travels to the grocery store. Okay, well, if you're going to travel in your car to the grocery store, first you got to get into the car, right? That's here. You're starting. When you get into the car, you're not moving yet. The car's sitting there. You got to turn it on. So you begin at no speed, right? You start at home. Right? You get the car. You start. Oh, your car. I guess not you. You're not driving your car. The car is started, and then notice it's going up, so it's increasing. Increases in speed until. And what do you think when it plateaus, when it stops? Does that mean the car is stopping? We're talking about speed versus time here. So as time is going by, you are staying at a consistent speed. Maybe it's 35 miles per hour. Maybe it's 55 miles per hour. That's probably 25 miles an hour. So if you're consistently going at the same speed as time goes by, that's fine. That's like you put on your cruise control and you just cruise on over. Right? It reaches speed limit and continues at that pace for a while. Then, right, so you could break it up into a few sentences. That might be better with these. Then notice what happens. It drastically decreases in speed. Well, you're probably close to the grocery store, so you're decreasing to then park. The speed. Until it stops. You're there. You have arrived at the store, right? So feel free to try the next one. Try it on your own and then check back to see what happens. And again, we can say these things in different ways, different words, and we've talked about a few different ways. I'm just picking one way and going with it. The graph below represents the balance of a savings account over time. Ooh, money. Well, notice it doesn't start at 0. It starts with some money in there. So the bank, the savings account, begins with some money in it. There's our y-intercept interpretation. We start, there's our 0 for a time, with some money. We don't know the exact money. It's fine. We just know there's some money in there. All right, and then it's going up. It then slowly increase in money. That sounds weird. Let's go for it. It slowly increases and stays consistent for a while, then increases again until it reaches its maximum, its relative maximum. We don't know if that's where it ends. Relative could continue later on somehow. But notice what happens then. Then, I guess we could put finally. It drastically, we put quickly, decreases. So someone's spending that money real fast until there is no more money in the account. All the way down to 0. They just drained it. All right, try this one if you want. All right, the graph below represents the height of a baseball after it is hit. Okay, this one's different than the golf ball. Notice it's not starting on the ground. But do you start with the baseball on the ground? No. Usually you hold the bat, and it's usually right around your body level. So when the ball is hit so far off the ground, some distance away from the ground, I'm not sure how to put that nicely, it increases and decreases. It increases and then decreases. To a relative maximum, and then slow. I don't want to put slowly because that implies we hit the baseball very slowly. And then we'll just put decreases until it hits the ground. Apparently that got a hole in one too. Just kidding. Usually, it hits the ground and it bounces a little, it keeps rolling, but going with just that. Just the initial first boom hit to the ground. Because notice if it went from here to like here and stopped, someone caught it. But it went all the way down to the ground to zero height. All right, final one. I don't know if you have this one on your paper, but I'll go through it anyways. Here we go. Discuss which situation is modeled by the graph. Okay, so notice it increases a little bit. Oh, distance from home. Okay, so you're further away from the home. And then you're walking the same distance away from your house. So maybe you're on the other side of the block. You're the same distance away from your house as time is going by. And then you're walking further and further away from your house, further and further and further. And then you're just changing direction, but you're the same distance away from your house. Which is interesting. So a jogger stops to take a drink of water, then continues to jog. Well, maybe, yeah, those could be breaks because you don't have to be continually walking. You're just distance from home. So you could walk for a little bit and then stand there for a little bit and then jog for a little bit and stand there a little bit. But that's kind of, yeah, this is more of a jog here and this is more of a slow walk. Okay, Ron walks to his friend's house. They drive to the mall, then return to Ron's house. Well, that keyword there, the returns to Ron's house, we know it's definitely not this one. Because then we'd have to come back down to the house. Okay. Kim walks to the bus stop, waits several minutes, and then takes the bus directly to work. That could be because it's walking, right? So it's a slower speed. It's gradually, it's stopping. She's waiting. And then that bus moves faster than she walked. And then she's at work. Ooh, that sounds good. That sounds good. I'm going to read the last one, but I think it's C. Mark rides his bike to the park and takes a short break before playing basketball for an hour. So that'd be just one increase and then taking a break. Yeah, I'm thinking C. C makes the most sense because the jogger would be this increasing would be the same as this increasing. And this says continue to jog. That obviously shows there's a plateau here. So it'd be kind of like an up, pause, up would be this one. This one would be, so that's why that's a no. This one would be they drive to the mall, they walk to the friend's house, maybe they sit there for a little bit, and they drive to the mall, and then they return back. This one would be like riding the bike, taking a short break, and then playing basketball might be like this. Maybe they're closer, further, depending on how it is in relation to the house. All right, so these are your notes. Make sure to review them both. We will be practicing these in class, and we'll be doing a few on our own.